Okay, this is the homework given for moles titration worksheet 8, question number 5. This is about an unknown weak acid whose grams per dm cube they've given to us. Titrate along with an Fa2 solution of NaOH, which is given to us as 3.4 grams per dm cube. The first part of the question talks about dilution, and it's diluted with Fa1, that is the acid. And I told you I gave you guys this volume earlier to dilute with, so we'll use that for calculations. Okay, we'll come back to this later, but that's the volume of Fa1 used to make 250 cm cube of Fa3. And you scroll down, and then the question titration starts, which is you fill a second beaker with Fa3, which is the new dilute solution of the acid, and you take 25 cm cube of Fa2 into a conical flask and you titrate that. And I told you guys that take this titer value for the calculation, and we will take that for the calculation in the next few steps. 25.30 for Fa3. Anyways, so moving on the next page, the first part is from the titration, blah 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 blah. That's the same thing as the previous part. The average 25.30, so that's 25.30 cm cube from the previous part. Then they've asked us to calculate the moles of NaOH that you pipette from a conical flask. Now for that you'll have to convert the grams per dm cube of NaOH to moles per dm cube. And if you scroll back to the previous page and I'll scroll up, I'll find out that it's 3.4 grams per dm cube NaOH. Now we convert that into moles per dm cube by dividing by mR. So it's 3.40 grams per dm cube divided by the mR of NaOH, which if you calculate happens to be 40, and you'll get a value of, let's see what that is, 3.4 divided by 40, that's 0.085. I'll go back to that. That's 0.085 moles per dm cube. Now from that they want us to find the moles of NaOH. So only one formula, N equals to CV. C is, we just found out, 0.085, and volume is 25 over 1000. And let's see what that is into, I'll take the previous value, 25 over 1000. I get 0.002125, or that's 2.125 10 power minus 3. So that's 2.125 into 10 power minus 3 moles. That's right here, 2.125 to 10 power minus 3. I'm sure everybody got that one right. Now there are two ways of doing the next part, which is use a tighter volume and the answer above to calculate the total moles in 250 cm cube of Fa3. Well, the easier or the longer way is you first find the concentration of Fa3. So let's find the concentration of Fa3. It'll be a little longer, but let's do it in 3 steps. First, the number of moles of the acid, which are going to be equal to the number of moles of the alkali, because the ratio is 1:1. So the number of moles of the acid happen to be, as the previous part, 2.125 into 10 power minus 3 moles in the conical flask. Now how do I find the concentration for this? Simple. Let me enter that. It is going to be number of moles is equal to CV, and number of moles are 2.125 into 10 power minus 3. C we do not know, but the volume here is the volume of the titer, because that's Fa3. And how much is that? Let's go up. I forgot. 25.30. So let's put that here. 25.30. and you'll get a value for C, which happens to be what? Let's see. Oh no, sorry, I forgot the thing. 25.30 divided by 1000, because that is the volume in dm cube. So let's calculate that. So divide this by 23.5 into 1000. I'll get 0.090426. 0.090426. 0.09046. I think that's it. 0.090426. Okay, 426. Now that's the concentration of Fa3. Next step, find the number of moles of acid in 250 cm cube of Fa3. That is number one of Cv. C is 0.090426. Same formula again, but now it's 250 cm cube. That's 250 to 1000. Let's find that out. Into 250 over 1000. 0.0226. 0.0226. Now we don't have to use the C1V1 because they've already done that for us. You now know the moles of the acid in 250 cm cube of Fa3. Now we know in dilution the number of moles remain the same. So the number of moles, the number of moles, why is it doing this? The number of moles of the acid in Fa1 taken will equal to the number of moles of the acid in 250 cm cube of Fa3, because the number of moles do not change in dilution. Using that principle, we'll go back and check what the titer volume was, dilution volume, I forgot. So let me go back. Oh, it's 38.10. I go back forward. I have that. So now the concentration of A1 is again the same Cv formula. The number of moles is 0.0226. C into the volume is, I forgot again. 38.10. Okay. 38.10 divided by 1000. So this divided by that and you get the answer. Let's find that out. This divided by 38.1 into 1000, I get 0.5933. 0.5933. So this is 0.5933. So this part is 0.59. No. Why is it doing this? Okay, then I want to find the MR. MR is simple because you know that moles per dm cube is equal to grams per dm cube divided by MR. So I replace the values. Moles per dm cube is 0.5, 9, 0.5, 9, 3, crap. I think the longer videos start showing this up. Grams per dm cube is, I forgot, let's go back to the previous part, 38.68. So it's 38.68 divided by MR. So it's this divided by that, or that divided by that. 0.5933, 38.68 divided by 0.5933. Let's do that. 38.68. So let me clear this. 36.86 divided by, I forgot, 38.68 divided by 0.5933. 36.8, crap, divided by 38.68, 0.5933. I hate jumping between 0.5933. So the pain is 65.2. I get 65.2 as the MR. Brilliant. Is there any more part left? That's it.